so let's take a look at number 43. 43 said, it's a challenge one. It says you take 5-question multiple choice quiz. So we have 5 questions. You guess on all of the questions, selecting one of 5 answers randomly. All right. So we have 5 possible answers each. You guess randomly on each. This is writing your givens down. It's reading it through and then writing your givens down. If you don't write your givens down, you're not giving your brain a chance to figure out what the heck is going on. All right. Then it says, what is the probability you will get a perfect score? So A is, we want the probability of a perfect score. All right. Well, for me to get a perfect score, it means you're choosing the right answer. How many of you guys agree with that? Okay. How many out of the 5 answers is the correct answer for each one? Jacob? 1. All right. So the probability that the first correct, then the second correct, then the third correct, and I'm going to keep writing this, 4th correct, and then 5th correct is equal to, well, I'm just going to write first. It's the probability of the first times the probability of the second times the probability of the third, and then so on. So here is my formula. It's the probability of getting each one of those correct. Well, the probability of getting one correct is simply 1 out of 5. Because 1 out of 5 of them is the correct answer. So, is this a replacement problem? A not replacement? Is this independent, deep? Is this both of them independent? Like, is this independent? Is this dependent? What do we have going on here? It's a multiple choice test. Are each one of these results from each question completely independent of the other ones? Do we have to worry about whether we replace or not replace? Jacob? Yeah, they're totally independent. It doesn't matter what you get your first one. You still have 1 out of 5 choices for each of them. So this is totally independent. So each one of these is going to be 1 out of 5. 1, 2, 3, 4, 5. Each one of them is 1 out of 5. So Colin, you're writing this down if you don't have this because you asked for this. Okay. All right, so now I just need to multiply everything together. So that's 5 to the 5th power, which gives me 1 over 3,125. All right, what else can I do for you guys? Matthew? 23. All right, so if I take a look at 23, it is super, super important that you guys are writing down what information you're choosing from. If you're not, then I don't know if you know what you're doing. All right, so for 23, it says we have 4 girls and we have 3 boys. All right, they volunteer to represent the class at an assembly. So we are, yes. Oh, sorry. Thank you for checking that. I appreciate you doing that. Does anyone want me to do 23? As long as I'm writing it down. Okay. Thank you for checking me, Matthew. So we want 23. All right. For 23, we are choosing from a bag of marbles. All right. So if we look at our marbles, we need to know what the marbles are. So we have 1, 2, 3 that are red. If you don't have this written down as you're given, you're writing this down now. We have 3 red. We have 1, 2, 3, 4, 5 blue. And we have 2 green. So that's what we're choosing from. So 23 said, well, first of all, it says you pick 2 marbles from a bag at the left. you pick the second one without replacing the first. So this is without replacement. This is without replacement. So I have the probability, we're looking for the probability for 23 of a red, then a blue. Well, the formula for that is going to be the probability of picking a red times the probability of picking a blue. All right, so Matthew, Andrew, you're paying attention. I do need to know how many total marbles there are. So I have 8 plus 2, we have 10 marbles. So I know how many total. So Matthew, what is the probability of picking a red? 3 out of 10 times. Well, I don't replace the red marble. Remember, you're assuming you get what you wanted. So we did get a red marble. So tell me now the probability of picking a blue. Well, I'm not replacing the red one. So what does that mean about the total number of marbles in the bag now? It would go down to 9, wouldn't it? I have to drop that 1 because we did not replace the red marble. So it's less by 1 because red marble not replaced. So it's really important you guys are reading the directions as to whether we replacement or we don't. For you to do compound probability, you have to know whether you have independent or you have dependent. All right, so from there, Matthew, I'm just going to divide out common factors here. And I end up with 1/6. Are you cool with that? Awesome. What else can I do for you guys? Colin, your hand had been up when his hand was up? Yep. All right, let's look at part C. Oh, I didn't do all the parts to it, did I? I'm so sorry. So let's finish up C, or 43. All right, let's look at B, just so we can do all of it. I'm so sorry I didn't finish that. B said, what is the probability? We have that 5-question test. All right, we want the probability that you would get a perfect score if there are 6 questions. So let's say that there are 6 questions. Who wants me to do part B now that I did part A? Okay. So part B, the probability of them being correct for 6 questions is 1 and 15/625. All right. So for part C, it says find the ratio. All right. So we want the ratio. Remember, the ratio is comparing things using fractions. Okay. And you're going to see the 2 word in there. So the words before the 2 is the numerator. The words after the 2 is the denominator. So we want the ratio of the probability of a 5-question perfect score to the probability of a 6-question perfect score. All right. Well, our 5-question perfect score, that was 1 out of 3,125. The probability of a 6-question perfect score is 1 out of 15,625. All right. So now I need to write a ratio based on that. All right. So that's kind of funky looking, isn't it? Okay. So what I'm going to do is, and remember, this is a challenge problem, so I do expect you guys to be challenged by this. All right. Technically, that ratio is 1 over 3,125 divided by 1 over 15,625. That's really ugly looking, isn't it? Okay. So that is division, though. All right, so if I was doing that division, all right, isn't this the same thing? So this is really 1 in 3,025 divided by 1 in 15,625. When I'm dividing fractions, what do I actually do? Because I don't want this fraction to have fractions in it. Can you guys see where I'm going with this? I don't want them to have the fraction to have fractions in it. I don't want the fraction to have decimals in it. So I'm going to go ahead and do this division and turn it into a regular old fraction. Does that make sense to you guys? Okay. So what happens, what do I do when I'm dividing fractions? Chris? Which one do I flip, the first or the second? The second, yep. So I leave the first one alone. I change my division to multiplication, and I flip the other one over. Well, we can just start dividing out common factors. All right, I would, just for the sake of trying it, when we have something this big, I'm actually just going to be like, okay, what's the chances of 15,325 being divisible by 3,125? I'm just going to try it. All right, it might not work. You might come up with a decimal, and at that point, you're just going to start dividing out common factors, but I'm going to try. So if I do 15,625, and I divide it by 3125, I do get a 5. So this ends up being 5 over 1 is my ratio. And you should be writing it as 5 over 1, not just 5. All right, the book, I don't like their answer because they asked us for the ratio. 5 is not a ratio. 5 over 1 is a ratio because it's in fraction form. So for every 5 of the 5 question 1s you get right, you're going to get 1 6 question 1 right. That's what that means. Does that make sense to you guys? Okay. What else can I do for you guys from the homework? Okay, put this away. Get your notes out. We're just going to practice some. This is the last section in our chapter. All right, so your test is going to be, like I say, either Wednesday or Thursday. It just kind of depends on how I feel, how you guys feel about what you're doing and your confidence with this section. All right, so today is the 16th. Practice compound probability. I'm going to show you a problem. I want you guys to do it. Oh, you know what I want to do? I want for you guys to get in groups of like 4 or 5, and I want you to come up with a compound probability problem. Just get in groups. Move if you want to move. Ladies, move together. Gentlemen, move together. Go ahead. Move wherever you want. If you have 3, that's fine. 3, 4, or 5, that's fine. Just get in groups of more than 2. So Peter, just join a group. Yep, just join a group. I'm going to give you 5 minutes, and I want you to come up with a compound probability problem. You can have with replacement, you can have without replacement. You don't have to tell them if there is replacement. Don't get too tricky. Don't have these be 5 or 6 things. Have be the max that you can do is 3 things. Do you guys understand? All right, go ahead. Now remember, if you're doing a story problem where you want them to figure out if you have to replace or not replace, that's fine with me. You don't have to tell them. All right, but the situation has to make sense where they can figure it out. All right, you have a couple minutes to do this because I want everyone to be able to practice each one of your groups. So don't take too long. Gentlemen, get going. Okay, guys. You guys should be writing. I'd like you to solve it. Yeah, you guys have to be able to solve the problem. If you can't solve the problem, other people aren't going to be able to solve it. So the problem has to make sense so you can solve it. So at least one of you solve the problem. All right, you guys, I'm giving you another minute or two, and then you need to get done. If you're done, go back to your seats so I know you're finished. If you're done, go back to your seats so I know you're finished. You guys should solve it. You have to know if it can be solved. But you can't give a problem that someone's going to be like, dude, I can't solve that. All right. Everyone go back to their seats. Go back to your seats, please. All right, so what I want you guys to do is, I need somebody from each group, one person from each group to come up and explain to us the problem, and you're all, listen, you're all doing each of these problems very quickly. Okay, so somebody whose handwriting we can read from each group needs to come up and show us. No, you're not. So you can show us what you're doing. No. No. Who has good handwriting from this group? Matthew, come on. Were you in their group, Matthew? Okay. I'm certain there's more than one person in the group with handwriting that's good, but I only need one of you. Excuse me, be quiet. Nick, I'm not interested. So cover up cover up everything but, there you go. All right, so you need to kind of read it to them. Let's zoom in a little bit so they can, that might be good enough. Okay, so go ahead and read what the problem is.
All right. Shh. You have a bag of marbles. There are 4 red marbles, 3 blue marbles, and 6 yellow marbles. Without replacing, find each probability.
All right, do this. You don't need every word. Every group is doing the other group's problem. So write down only the information that you need, and do this problem, please. Is this your group? Oh. What's the problem? Oh, we went to, what do they find the probability of?
Oh.
So let's take a look. Hang on one second. So we're finding the probability of picking a blue and then picking a red. You're finding the probability of picking a blue and then a red. He has the formula underneath this, and that's where he shows what he's doing. So probability of picking a blue and then a red. Yes. Exactly the same problem? Pretty close? Okay. Keep going. How could they copy you? There are totally different parts of the room. All right, keep going. All right, so show us what you did, Matthew.
The whole thing?
Yep.
All right.
So show us the formula.
So the formula was P, blue, then red would
Don't say P.
probability of blue, then red would equal probability of blue times the probability of red. And then probability of blue would be 3 over 13. And then without replacing, the probability of red would be 4 over 12. And you could divide out common factors, so 4 and 12 would be 1/3. You could do 3 and 12, but I did that. And then it would be 3 over 39, and you could simplify it to 1/13.
How many of you guys got 1/13? Awesome. Sweet. All right, just set that aside. My paper, yeah. My other group of the girls. Let's do a girls group. So Victoria, your group, come up. These are not as easy as they seem necessarily to put these together, are they? All right, I noticed that some of you are using very similar examples that we did in our book and stuff. So it's easy to fall back on those. All right, but it's harder to get more creative. All right, on your tests, I try to get a little bit more creative. All right, go ahead. Shh.
Someone is looking to adopt a pet. Victoria offers 5 dogs, 3 cats, 2 turtles, and 1 hamster. Isabella has already adopted 2 dogs. What is the probability that Kaylee adopts a cat and a hamster?
So I have one question for you. Are the 2 dogs that Isabella has already adopted from that group of 5 dogs?
Yeah.
Excellent. Go ahead. I like this. This is a good one. So you guys give me good suggestions for stuff. Okay, show us what you got.
So the probability of cat then hamster equals probability of the cat times the probability of the hamster, and then you get 3/9 times 1/8, and then you can divide common factors in the 3/9, which is 1/3, and then you get 124.
Excellent. Sam, what's up? Did you get that? Nice. So then why did I ask, is she adopting, is the two of the dogs in this group? Why is that important to clarify, Peter?
Because then you have a higher total number of pets.
Why? What did I not do?
Well,
Like, what do you have to do with the dogs that Isabel adopted? You have to subtract them off the 5 dogs, don't you? How many of you guys noticed that you had to take them off of those 5 dogs? Awesome. Okay. I have one more group. We'll do that. We'll do that on Tuesday. So remind me that I have one. You guys have the same one as the other one, though, right? Ladies, you guys have a similar one to the other one? All right. Do you guys have one that's similar to the other one? No. You have something that's different. So remind me on Tuesday. We'll do it on Tuesday. Okay. All right. You guys can go. You guys, please be good for Mrs. Courier tomorrow.